In this video, I want to introduce some of the basics of programming in C so that you're ready to dive into working on your programming assignments. In addition to watching this video, make sure you read all of the assigned sections from Chapter 1 of the Dive into Systems textbook, which goes into more detail on a number of these aspects of C. Here we have a simple C program. All this program is doing is computing 2 to the power 10 and printing the result, but it gives us an opportunity to look at some of the common syntax of the C language. The first thing to note at the top of the program is the #include statement, which is the equivalent of an import statement in Python. It brings in some library that we might want to use in our program. In this case, the library that we are importing is the standard I/O for input-output library. We'll include the standard I/O library in just about every C program that we write because standard I/O is where the printf function lives, which is what allows us to print output from our programs. The rest of the program consists of 2 function definitions. There's a function called power, and there's a function called main. Every C program needs a main function, and when we run that program, execution will begin at the start of main. So, when we run this program, we will begin with the first line of main, and we'll set x's value to 2, then set y to 10, then we'll call our power function to get the value of z, and then we will print out the values of x, y, and z. So, let's try actually compiling and running this program. I could do that from the terminal, but instead I will do it using the terminal that is built into Visual Studio. So here I can compile the program with GCC, our compiler, and the name of the program, pow.c. And if I want, I could give a name for the executable. I'll call it pow. And now, if I run / the name of my executable, we print out 2 to the 10th is 1024. So our power function did what we wanted it to, computing 2 to the power 10, but let's take a look at how we actually write that function in C. The first thing to note is that the power function is defined before the main function. If we had instead put this code in the other order, let's see what happens. Save it, rerun the compiler, and now it says that in main, we are calling the function power, but it hasn't been defined yet. There's an implicit declaration because when the compiler got to the power function that is being called in main, it doesn't yet know what the power function means because that function is defined down here. So we either need the power function to appear above main in our program, or we need to let the compiler know that it's coming by declaring it at the top and defining it later. So we can do that by copying this line, which tells us all of the information about how the function is called, and putting it above main with a semicolon. And so now, when we get to this function call in main, the compiler knows that there will be a power function, and here's what it expects to receive. And now if I save and compile, we're back to our program working as expected. The next thing to note about our C program is that all of our variables, x, y, and z in main, and base, exponent, and total in the power function, have a type identifier int. Each variable in C stores a specific type of data. So before we can use a variable, we need to declare it, giving it a type specification so that the compiler knows what type of data that variable stores. All of the variables in this program happen to be of type int, meaning they store integer data. But there are many other common types of variable, such as float, for storing non-integer numerical data. This lets us store fractional values. We also have the char data type, which stores characters, and we can use characters to make up strings, like the string that we are printing in producing our output. And we'll talk much more about these data types and the internal representation of these data types within the memory of the computer later in the semester. In C, when we print output, we use the printf function, which takes as its first argument a string. In C, a string has double quotes, whereas a character has single quotes. So unlike Python, where single quote and double quote are interchangeable, in C they have different meanings. In the hello program from last time, the input to printf was just a string, and that string was directly printed to the terminal. But here, we are also giving the variables x, y, and z, and we saw when we ran the program that x, y, and z all appeared in the output. The way that this output to the terminal was produced was by filling in these other arguments for the %d format characters in the string that we passed to printf. So we said %d, %d, %d in this call to printf, which means that we are looking for, as the remaining arguments to printf, 3 different integers to fill into these 3 spots. And so then when we print, x gets filled into the first spot, y into the second spot, and z into the third. %d is specifically for printing an integer, and if we wanted to print a variable of a different type, we would give a different % specifier in our printf format string. One more thing of note here is the syntax of a for loop in C. Every for loop in C is declared in the same way, with these 3 pieces separated by semicolons. The first of these is the initialization that happens at the very beginning of the first iteration of the for loop. So, when we are executing our power function, when we arrive at the for loop, at the very beginning of the first iteration, we execute this initialization. So we are declaring a variable called I of type integer and initializing it to the value 0. The second component is the loop condition that is checked before each iteration of the for loop. So, now that we've initialized I to 0, it will check whether I is less than exponent. If it is, then the body of the loop gets executed. If not, then we leave the for loop and continue below it. The third component is the loop update. The loop update does not happen at the beginning of the loop. Instead, it happens when we reach the end of the loop body. So, this I++ is a shorthand for I equals I plus 1. And so, this means that when we have executed the loop once and come back to the top of the loop, the first thing that we will do back at the top of the loop is we will increment I so that I will go from 0 to 1, and then we will check again, is I less than exponent, before executing the loop body. One more thing to note is that C is not whitespace sensitive. What this means is that the indentation of the program is purely for readability. The way that C tells when a line of code ends is by the presence of a semicolon. So if we were to forget one of the semicolons in our program, then C would think that the line we were on just continues onto the start of the next line, and that would be a compilation error. We can verify that by deleting our semicolon and trying to compile, and we get an error. Not being whitespace sensitive also means that every function needs to start and end with curly braces. So for both the main function and the power function, the function begins at the open curly brace and ends at the close curly brace. That covers all of the C syntax that I think I can show with this simple program, but let's try making some modifications to this program to show off a few more things. First of all, the way that we've written our power function, there is nothing about this algorithm that requires base to be an integer. All of this should work just as well if base were a floating point number. So let's try changing the type of base to float. And VS Code underlines with a squiggle, warning me that there's a mismatch between our definition of the power function and the declaration that we gave at the top, so we had better change it there too. And now VS Code no longer complains, so we can try compiling and running, and we got the same answer, and that's expected because we gave the same inputs. So let's try changing x to be 2.5, and if we compile and run, we get the same thing. The reason for that is we declared x to be an integer variable, and C was happy to let us assign 2.5 into an integer variable, and it just truncated that to 2. And so we were still calculating 2 to the 10th. If we change the type of x to a float, then we should also change the way that we're printing x, because here we are printing a decimal value with %d. So we want to print with %f. And now, let's try again. It tells us that 2.5 raised to the 10th is no longer 1024, but this answer doesn't look right, because if we multiply 2.5 many times, there should definitely be something accumulating in the decimal portion. We shouldn't get an integer as the result. Well, we have our power function, which is still returning an integer. So we can change that in both places. And we also have this integer variable total, which if we are storing all of our intermediate results in an integer, then that would also be throwing things away. So let's change the type of total, save, and recompile. Now we got a different answer, and this is much closer to the right answer. If we were to do 2.5 to the 10th in a calculator, we would get 9,536 point something. And the reason that we're missing that decimal portion is that we are taking the return value from power and assigning it into an integer variable. So we have the same problem as before, where we are losing everything after the decimal. So if we change the type of z and also change the way that z is printed, save, recompile, and run, now we get a correct answer. One more thing that will come up in the in-class activity is arrays in C. Arrays in C are a little bit like lists in Python, but are much more constrained. An array in C typically has a fixed size, and all of the elements of the array must be of the same type. Let's say that we wanted to print an exponent table for raising 2.5 to many different powers. We could do that by replacing these lines with a for loop that increments y through all of the different values that we want to raise x to the power of. So now, when we arrive at our loop, we will first initialize y to 1, then execute the loop, then increment y, and we will keep on doing that as long as y is less than or equal to 10. So when we increment y and it becomes 11, this will no longer be true, and so we will exit the for loop. So this should give us 2.5 raised to the 1, 2, 3 up to 10. But if we actually wanted to build a table of these values in our program, we could store that in an array. So instead of having a single integer z that stores the value we just computed, let's instead make z be an array that will hold all of the values we're going to compute. To do that, we declare z to be of type float, and then we use square brackets and give the size of array. So this is declaring z to be an array that holds 10 floating point values. Then on each iteration of the loop, we can store the value that we compute into a particular location in the z array. So we can do z brackets 0 would be the first element of the array, z brackets 1 would be the second element of the array, and so on. And so we want to base this on our loop variable, so we could store at index y minus 1, because we want to store in the first element of the array on the first iteration of the loop. So on the first iteration, we want to store at index 0, and on the first iteration, y is 1. And then here, we can print out z at element y minus 1. And now we get our same table. So later in the program, we can access and modify the elements of this array. For example, we could print out later %f end of line z at index 0. Now, what would happen if I were to print z at index 10? Pause for a moment here, think about what you expect to happen, and make a guess. And then we'll try compiling and running. That may be a surprising result if you are coming from a language like Python. If you did this with a Python list, you would get an error telling you that the index was out of bounds, because index 10 is the 11th element in the array, and we know that there are only 10 elements in this array. But C does not do any bounds checking for you. This means that it is up to you as the programmer to keep track of the size of your array and make sure that the indexes that you use to access elements of the array are in bounds. So what's actually happened here is that the elements of the array are all listed consecutively in memory, And if we try to access the 10th element of the array, C is happy to go past the memory that it allocated for the array and print out whatever happened to be in that memory. So this is a common source of bugs in C, and it is important that you as the programmer pay special attention when writing C code to the indexing of your arrays. This also means that there isn't a function call like Python len to tell you the size of an array. You as the programmer have to keep track of the size of an array, and you need to make sure that that size is accessible to you whenever you need it. A consequence of this is that if you are passing an array into a function, it is also a good idea to pass the size of the array into the function so that the code in the body of the function knows how far it can loop if it is looping through the array. I believe we have now covered enough C syntax for you to do the upcoming in-class activity. We'll talk much more about details of programming in C in upcoming lecture videos, and we'll get lots more practice in upcoming in-class activities and on homework assignments that you'll be implementing soon. As a reminder, please make sure that you also read the assigned sections from Chapter 1 of Dive into Systems so that you are ready to go for the in-class programming activity.